Okay, so we welcome back to system administration. Whether you're in the undergraduate class or the graduate student class, you should be either here live or watching this later. So what we're going to talk about today is we will talk about user groups, and we'll introduce access. We'll introduce controlling access to files is what that is. So if you're following along in the, whether you're on the HTML resources or on the, what is that, the PDF eVantage website, that's the one I'm going to be showing today, then this should be chapter 4, and we'll introduce chapter 5. Okay, so let's go ahead and start. Let me share. And just like always, just like we've done before, what I'll do is I'll spend the first hour and maybe a little bit more introducing. What we'll do today is I'll do the first hour will be chapter 4. We'll go through all of chapter 4. And then in the second hour, I will show you using that virtual machine that I have CentOS running on. I'll show you some of what we've talked about in chapter 4, and then we'll introduce chapter 5. Okay, so that's the plan for today. All right, so let's just go ahead and get right to chapter 4. Oh, I'm sorry, I said that wrong. Not chapter 4 and 5, chapter 5 and 6. So I apologize for that. Okay, so what we're going to be doing today for the first hour is we're going to be talking about chapter 5 here, managing local Linux users and groups. Okay, now again, I want you to be running this so that I would like you to be using CentOS or Red Hat for this course, because that's what all the material is based on. It's not to say that what we're teaching here in this course is only useful for Linux, right? So system administration, there's lots of different operating systems that may get used for the purposes of system administration. And basically what it is just like with anything, just like if you learn how to program in Java, but then you maybe get a job or an internship that requires you to use Python or C, you can use some of those tools, some of those skills that you gained with your Java course and just modify it a little bit for the syntax of Python. Same thing here. This is, we're teaching you basics of how to control, how to manage users and groups in Linux. You'll use those tools if you end up, for some reason, if any of you end up being a system administrator one day, which would be great. It's a great position to have. And if you end up having to use some other operating system, such as OS 10 with Mac OS or with Windows operating systems, or even sometimes maybe if somebody makes an in-house operating system or some other flavor of Linux even, you can use the tools you've gained here. Okay, so these are the objectives here and the sections. This is what we're going to do today in the first hour, and we'll practice this in the second hour again. Okay. All right. So basically first thing we kind of have to identify is what is a user. Okay, so now a user, you might think, oh, that's a person, right? That's a person that's using our system, right? Well, yes and no. I mean, that is traditionally how we might think of a user, as being a person who's using a computer. But in actuality, a user can also be an automated process. User could be an ID that is just one of many IDs that one person might have. For example, I have a user ID for the Octanese university system, the Joseph Leday at octanese.edu.tr, right? But I also have a user ID for my Gmail, and I have a user ID for other things, for Facebook. I know I'm old, I use Facebook, and none of you guys do. Other people have user IDs for Instagram or Twitter, but some people, you probably know some people who have multiple usernames, multiple IDs for some of those services, right? So like, for example, for me, I have a Gmail account that many of you probably know because it was the teacher account for a previous course that maybe you had with me on the Google Classroom. I also have a separate Gmail account that I use what I use is I use it to act as a student in those courses so that I could see what you guys see. All right. So I have two separate Gmail accounts. One of them, obviously my main one, gets used a lot more often than the other, but I have two users on the same system. Okay. And so in the same way, a user is not just a person. A user is a particular ID in our system. Okay. And the user is going to execute processes, right? And is going to create files, and we're going to associate those processes and those files with a particular user with a particular ID. All right. So if we want to know some information about the user that you're currently logged in as, you can use the ID command, and the ID command will tell you your user ID, your group ID, what groups you belong to, if you belong to more than one. So everyone, what we'll see here in a couple of chapters, in a couple of sections, when we start talking about groups and stuff like that, is every user is going to have a single primary group, but they're also going to have multiple other groups as well. Okay? This information tells us that. If we want to see the user associated with a file, we can use that ls-l command. We've used it before, we just didn't necessarily always explain what it was. So this highlighted column here is the username that owns the file. Okay, so the way that you would see this is the username, this is the group that the file belongs to, this is the name of the file over here, or the folder. In this case, it's a folder. This we'll see later in later chapters how to read all of this part here. Okay, what this DRWX and all that means. Okay, so D tells me that this is a directory. This is a folder. So this folder is owned by the GDM user and it belongs to the GDM group. This folder belongs to the student. Student is the owner. Student is also the name of the group for this. And then this right here, this dash tells me it's not a folder, it's not a directory, it's a file. And so this file, this postconf file is owned by the root user. And we'll learn about what the root user is here in the next section. Okay. If we want to view some process information of what's going on, what processes are running, right? We can use that ps command. Remember these options here, the A is an option for the PS, is all processes, and we want to view the user associated with the process, so we use the U option as well. So when we do this process command, PS command, we see who the users are, we see what the command is over here, what the process is running, and we see some other information as well. So this tells me, well, where it's going. This tells this is the process ID. This is some information about the CPU percentage and what RAM is using and stuff like that, and when these things started. Okay. All right. Notice this one. When you run this PSAU command, it's telling you all the active processes. Well, when it goes to list those out, you should always see this one because this is an active process at the time that it's listing it out. Okay. All right. All right. So if we wanted to know some more deep information about our users, all that stuff is stored in two files, actually. The Etsy password file stores the basic user information. Then we'll see on the next page the Etsy shadow file is where the password information is actually stored. I'll show a couple of examples of this and when we do the CentOS example in the second hour, so you can see this better. Okay, but this is the order. So when we look at the Etsy password file, what we will see is a bunch of lines of username, password, user ID, group ID, Geckos, we'll talk about that, home directory, and shell, okay? So what we'll see is password is where the passwords were kept before in an encrypted format, but now they're on the Etsy shadow file. So we won't see any useful information there in the Etsy password file. We'd have to go to the Etsy shadow file to see that. So the user ID is a unique number that identifies the user. Okay, this is very, very useful because that's actually how the system IDs you, identifies you. It doesn't identify you based on your username, which is also has to be unique as well. But that is, it's harder to search things with a string, as I think those of you who've had my database class, I've talked about that before. It's much easier to search things that are numeric, and so your user ID is a numeric value so that it can easily find who the user is. Okay, GID is the primary group ID. We'll talk about that, like it says, in a moment. All right, Geckos is arbitrary text, which usually includes maybe like the user's real name, but it's not really all that important for our purposes. All right. Home directory is the user's personal data and configuration files. It's where their home is. So remember, we talked about to go to their home directory, we would use that. You could do that CD tilde, that little squiggle line. That will bring you to their home directory. This is how it knows where to go in order to do that. Okay. Shell is the program that runs as the user logs in, right? So basically, this will be the user's command prompt. Okay. So what is a group? Just like users, groups will have a name and a group ID, a unique number for a group ID. Right now, we could go into the Etsy group file to look at what the local groups are, but that's for local groups. Okay. Now, as I said before, every user is going to have a primary group. Now, normally, what happens? Well, actually, what happens when you create a user, and we'll see this in just when we in the second hour, is when you create a user by a certain name, they get a group named that as well. Okay, so you create a student user, a student group is automatically created, and the student's primary group is the student group. Okay, if you were to create a user like teacher, right, named with the username teacher, we would create a user with the username teacher, a group with the name teacher would be created, and teacher's primary group would be teacher. Okay, so when a user creates a new file, what usually happens is they own the file as the user, the group they belong to, their primary group, owns the file as the group. Okay, so we saw that on the previous page. I'm going to skip back just a moment and show you that. So remember this when we looked at the directory and the file here. Notice the user that owns it and the group that owns it are the same in all three of these situations. Okay, that is normally what happens. Okay. Again, as I said, it's normally with the same name. Now, users might be added to some number of supplementary groups. So this is what we use for being able to gain access to files that you don't own. Okay? Because what we'll see when we talk about managing access to files in the next chapter is that we create files, they're owned by a certain user, they're owned by a certain group, but they might also have access rights to people outside of the group, to everyone. Basically, everyone who has a login on the system. Okay. Now, what we might want to do is we might want to say, well, you know, I really only want owners and groups to have certain types of access, read and write and execute access to my files. So what I'm going to do is I'm going to change the access rights to make it to where no one outside of the group and no one that's not the user can gain access to this file. Well, what if we find that someone who's not the owner or the group needs access to this file for some reason, and they need to be able to get to it, make changes to it, you know, things like that. And then we can't just like email it to them or something like that, because we need to make it simpler than that. Well, we can either change access to make it to where everyone could have it, or we can add that user to a group that owns the file. Or what we oftentimes will do is we will change the group that owns the file and just add both the user, and then we'll add any users that need access to the file to that group. Okay. That'll become clear, I think, as we do some. I think that'll become more clear as we do this more in the second hour. Okay. So that ends section 1. There's the practice here is just a quiz. I've uploaded for chapter 5 and for chapter 6. Actually, let me confirm that, because as I said, I was wrong on the chapters. I had the wrong chapter numbers. Practice. Yep. Okay. I have uploaded all of the chapter 5 and chapter 6 exercises and quizzes as PDFs. So you can go and look at those. So for practice, but we won't go through that here today. Okay, not in class. All right, go ahead. I suggest what I would suggest you do. Let me go back here. Is take this quiz, right, and look at it and see if you can know the answers before looking at the answers. Okay, go ahead and try the quiz yourself just for practice, and then look at the answers. Okay. All right. So one of the things that we talked about before was that the root user was what we call the super user, or the kind of the big admin, like the one that can do anything. Okay, it's a power user. It can do anything on the system. Okay. Now we did say in a previous lecture that it was unwise, and it's generally said not to log in directly as the root user. And so whenever the system starts up, you have a login screen. You can click on different users that are in there to try to log in as them. Root is not given as an option, but what you can do is you can click on, log in as some other user that's not listed, and you could type in ROOT, and then if you know the root password, you could type the root password, and you could log in as the root user. That is a possibility. It's generally said not to do that, and the reason why is because the root user has so much power. There's really not a lot of checks on things they try to do. So if a root user does something that a typical user might not be able to do, the system may not give a warning message of any kind, but then the root user the person logged in as the root user could end up making a huge mistake and messing up the system. Okay. All right. There's also there's not much tracking of what the user does when they're logged in as root. Okay. All right. Now, again, root has this whole unlimited power. Let's see. So then the question becomes, what if I need the power of the super user, but you just said, Hoja, you said don't log in as the root user. So how do I get there? What do I do? Okay, there's a couple of different ways to do this. All right. Now, one is the SU command. Okay. The SU and possible dash command with an optional username. Okay. Now, when you do this, SU say dash says I want to switch over to this wherever I'm going to, right? The dash says I want to go to their home directory. Okay. So what you see here is SU dash. Right. Then I need to type in the password, and then I will be logged in as the root user on the system, but I'm still in my account. So it's not that it switched me over to, like it didn't switch my whole desktop and everything over to the root desktop. It just gave me access into the root account. Now this, we use this if there are a set of commands. Like if you're going to be operating as the root for a while, if you need to do things as the root for a while, then what's going to happen is this will let you stay logged in as the root for as long as you don't type exit, basically. Okay. All right. Now, there's another way that we can run commands with great power, with our super user power, and that is the sudo command. Okay. So su, oh, by the way, I didn't say this. I think it says it up here. The su command, or the su command, it stands for switch user. Okay, so what we're doing is we are switching our user to this username. Okay, and again, the dash puts me into this other user's home directory. So it's kind of like an it's not only switching me into that user, but it's also changing my directory to be my working directory to be their home directory. Okay. All right. So so that's the su command. That's like becoming root in a sense. Okay. But what if I don't want to become root? I just want to run like one command as the root. I don't want to go through this process of switching to them, switching to the root, running my one command, and then switching back to me. I just want to run one single command. Okay. Well, we can do that using the sudo command. Okay. Now, you have to be included in the sudoers file, right? But sudo basically switches you to root just for the one command that follows it, okay, and then switches you back out. Okay. Now, one thing it will require is it will require you to type in your password. So up here we typed in the root password. So again, we still had to know we don't get access to root just because we know our own password. We have to have access to root in this situation. We have to know the root password. Okay, so there is a level of security there. So we're not just allowing any old user to have access to root just because they happen to know their own password on the system. This one requires that they know the root password. So we've trusted them. If they know the root password, we've trusted them enough that we feel that they can have access to the root user. Okay. Here, however, with the sudo command, it'll only run this one command as the root, but we know our own password here. Okay, so why do we know our own password and not the root? Well, in this situation, what happens is that any commands that are run using the sudo command will be logged in a file so that we know who did it. Okay? This is a little bit of security. Now, this won't stop the command from being run. It's not that it's stopping the command from being run, but there is accountability. So if, let's say, user Joseph, for example, runs a sudo command and deletes somebody else's user, deletes his boss's user account, because he's mad at him for some reason, right? If he does that using the sudo command, because he doesn't know the root's password, we don't trust Joseph enough to give him the root password. No. All right, but he can run a single commands as root using the sudo command. So he goes in there and runs sudo, he deletes his boss's account, and he types in his own password, and he thinks that, he's done something good. He won't ever get caught. Well, boss comes in and says, why don't I have my account anymore? What happened to my account? Well, system administrator, you'll go into this file, you'll take a look at what's going on, and you'll find an entry for deleting of the boss's account, and you'll see who did it. And you will see that Joseph did it. And guess what's going to happen to Joseph then, right? So, all right, so Joseph needs to be more careful, all right, and not delete his boss's account. All right. So that's kind of the two ways that we can gain super user access, right? And here's an example of where we're looking at the file, the var log secure. So we're looking at the last, X number of commands. Right? And notice though we had to use the sudo command because our user student does not have access to this file on their own. Okay, so in order to see what's in that file, they will need to use the sudo command. Well, notice that that's in the file. Right? We, as student, use the sudo command to run the tail var log secure. Okay, all right. So we see that even the command we're currently running got placed into that file that we're looking at. Okay. So this is what that system administrator would see if we tried to delete our boss's account. Okay. If we want to see who's in the sudoers file, right? We can see that using the cat command for the sudoers file. Okay. All right, so that ends the how to gain super user access. Here there's a practice. What we'll do is during the second hour, we will go through the practices. And then what I'll do is leave as an exercise for you is for you to do the lab on your own. Okay, so we'll go through if you have this, if you have, like I said, you have access to the PDF on the folder, so you can follow along with this when we do this in about 30 minutes, when we start this about 30 minutes. Okay, all right, let's move on. So now that we understand what a user is, we understand what a group is, we understand how to gain super user access, right? We want to know how to manage local users. We want to know how to manage local users, to create them, to modify them, to change passwords, to delete them, because sometimes we do need to delete users. Like I said, don't delete your boss's account, and I stand by that. Do not delete your boss's account. Okay, bad idea. All right, but sometimes as a system administrator, you might need to delete an account if somebody leaves the company, if somebody gets fired, if, morbidly, if somebody dies, if something happens like that, we might need to delete their account. Okay. So basically, it's just like with everything else we talked about. There's a set of commands and a set of options. So if we do user add as a command with a username, it will create a user with that username. It will automatically create their user ID. It'll create, like I said, their group with that name, with a group ID. Okay, and all the user IDs will be, as we create them, we'll have numbers above 1,000. Okay. Basically, the first user you create is like the 1,000 user, and any user after that just get increments by 1. Okay. Now, user mod is what we can do in order to lock users, unlock users. We can set the primary group or add them to supplementary groups. Okay. We can also use the user mod to change their password, but we can also use the password command with the user ID in order to change their password as well. Okay. Let's see. Yeah, we can do lots of different things. All right, we can append to the supplemental groups. We can, like I said, we can lock or unlock an account. This is generally used for if we want to keep someone from logging in, but we don't want to delete their account. So just, as an example, these things happen. Somebody leaves the company, but we're not sure if they were very happy when they left, or we're kind of concerned that they may, eventually try to do something, with the access that they had to the system. Well, we can lock their account because instead of deleting it, because by locking it, we can still have access to their files. We can still have access to the things that they did, because they may have worked on some projects that we still need the files that they created. We still need the files that they own, right? Deleting it might delete, especially if we use the -R, will delete their home directory. It'll delete everything, right? And so locking will allow us to keep them from getting in, but at the same time, allow us to keep access to their files. Unlock is, again, it's, as the name implies, is to unlock an account. Now, this isn't necessarily just because we locked it. It could be that they entered the wrong password too many times, or their password expired. There's going to be, what we'll see when we do managing passwords is you have password expiration, and if it goes too long, it'll even lock the account, these kinds of things. So we can unlock the account using the -L option. So user delete, user del deletes a user, right? And it just removes the user from the Etsy password, but it can leave the home directory, so it can still stay there. Okay? This can cause some future weird things if we try to create a new user with the same name, because it may tell us, oh, there's already a user home directory by that name, you know. And so, you know, if we don't remove everything, it can create future problems if we try to create a user with the same name. Okay. So sometimes we might want to use this -R option so that it deletes both the user and the home directory, and kind of just makes it like the user was never on the system, in a sense. Okay. All right. Again, when a user is removed without the -R, the system will have files that are owned by an unassigned user ID. Okay. So the files will still be there. They just won't be owned. Right. They just won't be owned by anybody that's there, as we see here. Right. This, instead of having a user ID, you get this user number, right? You get, instead of having a username, rather, you have this user number, because why? That number does not exist in the Etsy password file. And because it can't find it there, it just shows us what the number is, what the user ID is. Okay. Okay. Again, ID, like I said before, will display your user information. ID with a username will display information about that user. Pretty straightforward, simple. Okay, password with a username can be used for changing the password of that person. Notice if we don't include the username, that's how we change our own password. All right, by the way, you cannot change the password to something that fails any kind of checks. So there's all kinds of rules about length of password and what types of characters have to be in there and stuff like that. If you do this without being the root, right, then it won't allow you to change it to this other thing, to this thing that won't work. If you run it as the root, right, you can set a password to anything. So you can change the password to something that does not fit a good password requirement if you are logged in as root, or if you are running using the sudo command. But if you just run password for someone else, not as the root, or if you run password for yourself rather, not as root, and try to change it to something that does not is not considered a good password, it won't allow it to go through. Okay. Again, one of those things that root can do that we can't. All right. I won't spend too much time talking about user ID stuff, but I do want you to know that user ID 0 is the super user root. So it's actually not that the word root is what's important in terms of being the super user. That super user name could be anything, okay? But it's about the user ID 0 is what's important here. Okay? User ID 0 is the super user. The name is not so important, but we keep a standard naming convention so that everybody knows root is it. Okay. There's some other system users between 1 and 999, and again, like I said, 1000 and above are all of our regular users. Right. Let's move on into groups. Again, we'll do this in the second hour. So Okay, groups, how to manage groups. So just like with users, user add created a user, group add creates a group. So group add with a name will create a group with that name, okay? Now, we can specify a group ID to give to that group as long as it doesn't already belong to some other group. So we can group add a group ID 5000 to this particular group. Okay. All right, we can group add the -R. All right, we'll create a system group from the range. So from that range of 1 to 999, okay, to make this a system group. We can modify existing groups using the group mod, just like with the user mod. So notice there's a lot of standardization here. There's a lot of user add as a user, group add as a group. User mod modifies a user, group mod modifies a group. All right, and so we can change a group name, right, to specify a new name. Right, we could specify a new group ID if we want to change the group ID for some reason. And then just like with the user delete, user del, group del deletes a group. Okay. Be careful with the group delete, because if anybody belongs to it, if it's the primary group of an existing user, right, it has to make sure that no users belong in that group. Okay. A user has to have a primary group. A user does not have to have, is not required to have supplementary groups like other groups, but every user must have a primary group. Okay. So user mod can also alter group membership. So user mod -G, group name, okay, will change a user's primary group. Okay. So mod G student, so I'm modifying the student to be in the student group. Okay, which that's what they should have had already anyway, but now we're changing it. Okay. We can add a user to a supplementary group. Now notice that we change a user's primary group because a user can only have one primary group. It cannot have more than one. Okay. But we add them to a supplementary group. So if we user mod -A capital G, then we are adding wheel to the Elvis group. Okay. Oh, sorry, I'm the other way around. We are adding, I'm sorry, I did this in reverse. Student and student. This is the group name. The second student is the username. Had it reversed. Here, the group name is wheel. The username is Elvis. So Elvis is being added to the wheel group. Now that does not change his primary group. This just adds him to wheel as a secondary group, as a supplementary group. Okay. The -A makes it append. So basically, if it was just -G, capital G with no A, what would happen is Elvis would be added to the wheel as a supplementary group, but any other supplementary groups he'd been a part of would be gone. Okay. So the A makes it append, makes it add him to that, and does not change his existing membership. Okay. So just like before, we'll practice through that in 15 minutes or so. So I think we're on the last section now. Okay, managing user passwords. Okay, so very quickly here. We talked about that the passwords were in the etc password file. It's world readable because we have to be able to, we have to be able to see those passwords. Okay. What that means is anyone on the system, anyone logged into the system can read that file. Now that doesn't mean they can write to that file. We'll talk about that in chapter 6, I believe, with access to files, or we'll talk about what the difference between read, write, and execute are. Okay, but anyone can look at this file, can see what's in it. Okay. So when we look into that file, what we will see is 3 fields all separated by this $ here. Okay, so we have the $ followed by what algorithm is being used. Okay, what algorithm for encryption is being used. Okay. Then the next section between the next 2 $, and I actually caught the second $. I didn't need to do that. This section here, right, as we see down below, this right here, is the salt used to encrypt the hash. Now, that's all having to do with encryption, which is more of a cybersecurity thing. So that's beyond the scope of this class. So I'm not going to talk through it thoroughly here. But I believe you're all either taking or have taken a cybersecurity class, so you should understand that stuff for the most part anyway. Okay. So, all right. So the salt should prevent 2 users with the same password from having identical entries in the Etsy shadow file. Okay, so this is about encrypting their password. So, and then finally, the last thing after the last $ is the encrypted hash. So this would represent what the password encrypted is. Okay. All right. So when the user logs in, first thing it does is it looks in that Etsy shadow file. Okay, and it combines, I guess the first thing it does, it looks in the Etsy password file to find if it even has an entry for that user ID. If it finds it, then it goes to the Etsy shadow file and it tries to find their entry there, right? And it compares the salt used on the password that was typed in, right? Encrypts them both using the hashing algorithm, and then compares what it gets as a result with what's stored as the encrypted hash. And if they're the same, right? If they're the same, then it lets them log in. So it doesn't have to store their password in the format that they typed it in. So if their password was student, for example, it does not store the word student anywhere. It stores an encrypted the word student. No, it's not there. Okay. All right. So again, there's some section here. Wait, did we go too far? Oh, here. Okay. So in the Etsy shadow format, all right, so that's just the password information, right? You'll have the username, the password, and then some other information that we'll talk about in just a moment on the next page. So the login name, the encrypted password. If it starts with an exclamation mark, it means that the password is locked, which means that for now, the user is not allowed to log in. Okay? The date of the last password change. This is represented as the number of days since 1970-0101. If you've ever heard anybody talk about the Unix, what is it, the Unix apocalypse or something like that, or the Unix version of Y2K. Now, I think most of you are too young to remember Y2K and the year 2000 and the concern with when all the computer clocks were going to switch over from 1999 to 2000 and all the concern there. There is this other date that's coming. I think I'm not sure when. I'd have to look it up. But one of you may know. Actually, you might be able to comment in the chat there about it. That when the Unix system kind of does the same thing, when it runs out of milliseconds since 1970, that we could be facing a similar concern on a lot of the Unix-based systems. So I'll look it up during the break and we'll find it. Okay. I know it's time for the break now. Let me finish this because it's only got 1 page left, and then what we can do is start a little bit late on the second hour. Okay. So anyway, the date of the password change, the minimum number of days before a password may be changed. So basically, if we don't want them to be able to change their password too frequently, okay? So if they've changed it already, that we need to wait a certain number of days before we can change it again, okay? the maximum number of days before a password must be changed. So if they run out of time, we want them to change their password every 30 days, every 90 days, something like that. Lots of companies I know have this, like, they force their employees to change their password every month. So it's an attempt at security, but I'll tell you, my mother-in-law, my wife's mom, she works for a company like this. She basically has a password she uses and then just adds on the end the month, the 3-letter month. So basically right now her password is whatever it would normally be, like her base password plus NOV, So, so if somebody learns her base password, they know what her password is, right? All year long, even though she changes it every month. Okay. There's a warning period to let our users know where when their password is about to expire, right? But it's not expired yet. Right. The number of days an account remains active after a password has expired. Again, if a password expires, the account can remain active, right? Where they can still log into the system and the system will require a change in their password, right? But after that number of days, the account will become locked and we'll have to unlock it. And you remember how to do that from a few pages ago. Okay. Account expiration date, when does the account expire? And then a blank field that isn't used right now. Okay. So we can change, right? A user situation, change the date, right? The last date change to force a password update on next login. So basically we'll say it's been 0 days since you changed, you need to change it now. Okay. Could also do a -L, right? List the username's current settings. This is for password aging. The -E will tell us when to make the account expire. So E is for expire. We can also use the date command to calculate a date in the future. So if we were to say, let's use the date command to figure out what's going to happen in 45 days. We want the account to expire in 45 days. And then take this, Saturday, March 22nd, March 22nd. It says 2014, but 2020, whatever, 2021, whatever. And we can say it should expire then. Okay. Okay. And then I think this will be the last page before we get to the practice and the break. Okay, so we can use the chage command to be able to expire a password. To expire an account. Right. Once that expiration has happened, right, the user to the system, right. But we can also use the user mod to lock an account. So those are two different ways that we can restrict access. Right? So we can make their account expire in a certain number of days, which means they would not be able to get into the account after that. We can also lock it immediately with the -L command. Okay, so here you see we can notice that the user mod, we require the sudo command to be able to run as root because our student user doesn't have access to do this. So we do the -L to lock the Elvis account. Then when we try to get into the Elvis account, it tells us we cannot do that. Okay, right. So the administrator may lock and expire an account. So if we lock and expire, the number of days since 1970, so the expiration happened 1970, January 2nd. All right. So we locked it and expired it all in one shot. So now Elvis can't get in the building. Right? Elvis cannot get into his account anymore. Okay. All right. So we can later unlock the user account, right? And we would also need to change the expiration date if we needed to be able to get into the account again in order to get access to some of their files and stuff like that. Okay. Now, there is also this no login shell. If we add the user's name to the no login list. All right, but then what happens is that if the user tries to log into the system through a shell command, that it won't allow it to happen. It'll say that the account is currently not available. All right, now what this happens, the reason why we may do this is that if we need a user to be able to have an account, because we need them to be able to do things, we need them to be able to create files, we need them to be able to change things, to have access, but we don't need them to be able to have an active connection through a shell command, through a terminal, right? For example, a mail server may require an account to store mail and a password for the user to authenticate with the mail client to get mail. But if we have a mail server, they don't really need to have access to use a terminal to be able to use the system, right? So if we do that, then what we can do is we can make them a no login, part of the no login group. Sorry, not group. Put them into the no login list. And what will happen is if somebody tries to log in as that student, it'll just say that's not available. Okay, so they may still be able to do stuff, upload and retrieve files through web, through FTP and stuff like that. But it's so that they can have access to the system even if they don't need to have terminal access to the system, shell access. Okay. All right. So I think that's, yep, there we are, practice there. So what we'll do is, like I said here, okay, so we got out quite late for our break. So what we'll do is it's 10:27 according to my clock. So let's do 10:40. We'll start up again. Okay, go, get more coffee and tea if you found yourself falling asleep. And what we'll do is we'll go through the 4 practice exercises together, and then we'll move on to chapter 6 in the second hour. Okay. All right. So I'll see you guys in about 13 minutes, and that's it.